Okay, 10.4 is got a really cool patterning thing in it. I like patterns. I think they're kind of cool. And so it's called Pascal's triangle, and we're going to use Pascal's triangle to do some fun things that make combinations maybe easier to work with, or at least different to work with. They give you another option. So first, the leading idea. Pascal's triangle beautifully reveals patterns in relationships and counting, and it really does, showing how simple numbers combine to create complex and harmonious structures. In a similar way, faith in God invites us to see the order and purpose woven through life's complexities. Just as each number in Pascal's triangle builds on those before it, faith grows step by step, connecting moments of understanding and experience into a greater whole. And that is exactly how your life unfolds. The things that you are doing in your life right now hinge on what you have done before, for good or for bad, right? They do. Things you did in high school, the things that are in your home life, all of that combines and goes together. Pascal's triangle is an unending triangular array of numbers. Pascal wrote about it in 1653, but evidence shows that it was studied in China and India as early as 1100 or before. This is old, very old. A lot of times Western culture gets the names of things because it shows up in history books that way. But there is a recognized feature here that this predates Pascal. He didn't know about it. He still discovered it in the same way, but it predates him. And I want to show you how Pascal's triangle works. I'm going to set this down so that I can make sure I keep things level. The more level that you write, the easier this is going to be to look at later, okay? So you're going to create a triangle where you're going, first of all, I'm going to write down here. I'm going to write the row number here on the left. And over here, we'll do that later. So we're going to have, we're going to call it as row 0. We're going to do 1, 2, 3, 4, 5, 6, that's not a 6, 6, 7, and 8. We're going to do 8 rows of the triangle. This triangle does not stop at 8. If you wanted to go and print out a triangle for Pascal's triangle that was 52 lines long, because 52 is where we were just working with back in our cards example, you could do that. I feel like that would be a waste of time, but you could do it. It exists. So Pascal's triangle looks like this. There's a 1 at the top, and that 1 is on row 0. Okay, so that 1 is supposed to be lining up horizontally with row 0. I really should put lines on this slide. That would be really helpful for me. Okay, so the 1 on the top, on either side of the 1, going down at diagonals, are going to be a couple more 1s. So it looks like this. So row 1 has 2 1s on it like that. Okay? And everything along the outside of the triangle is going to be 1s. I mean, this is one of the patterns of it. It's just going to have 1s along the outside. Everything on the outside is going to be a 1. So the next row, row 2, is going to have a 1 on the outside at the beginning, a 1 on the outside at the end, and in between it's going to have the number 2. So row 2 has a 2 on it. Okay? Row 3, I've got a 1 on the outside of each of the pieces, like so. And then I'm actually going to have 3s in the middle, a couple of them. Row 4, going to have 1s on the outside. It's going to have 4s building sort of outward in, and the middle number itself is a 6. I'm going to do one more row, and then we're going to talk about where these numbers are coming from, okay? 5, I've got 1s on the outside, 5s as I build my way in, and then there's actually 10s next. So let's look at how these numbers are coming about. We already talked about the 1s on the outsides and so forth. Every number that I pick, I'm going to pick the first 4 here, is coming about from the addition of the 2 numbers above it. This 4 comes from this 1 and this 3 added together. Okay? And that's why the 1s are happening. There's only 1 number at a diagonal above it, so it's still a 1. So we're going to build row 6 in the same way. It's going to start with a 1, and it's going to end with a 1. And underneath this 5 and the 1, at the beginning and the end, would be the number 6. And under the 10 and the 5 would be the number 15. And under the 10 and the 10 would be the number 20. Let's do row 7. 1 and 1 on the ends. 7 and 7 are next. I have 6 and 15. 21. And there's symmetry, right? Once I get one of the 21s, I'm going to get the other one as well. 15 and 20. 35. And there's 2 of those in the middle. So it either duplicates in the middle or it's a single one in the middle. I mean, those are 2 options. Row 8. I have a 1 and the 1 on the outside. I have an 8 and an 8 as it builds in. 7 and 21 give me 28. So I have a couple of those. 21 and 35 give me 56. So I have a couple of those. And then my middle one is 35 and 35, which is 70. This is Pascal's triangle. Okay? So what we're going to do when we come next time, is we'll finish this front page, is that we're going to make the connection of how this Pascal's triangle, with all these lovely patterns, and there's actually some more patterns over here too. Check this out. Let me do this real quick. Over here on the sum, that's on the right-hand side, we can actually create the sum of each row. Row 1 is 1, row 2 is 2, row 3 is 4, and then I have 8, 16, 32, 64, 120, I missed one. 64, it's 128. I missed one, it's 256. I'm off on my lines. It goes to 256. Do you know what these numbers are? They're powers of 2. Another beautiful piece of the patterns that are in this. But what we're going to do next time is we're going to relate these patterns to combinations. And you're going to see how you can use Pascal's triangle to find combinations as well. And we will pick up there next time.